Hello, everyone. We will get started at a couple minutes past the hour. Well, just to give folks to get a chance to join. And if you have any questions during the webinar, please feel free to put them in the questions portion of the webinar tools and or in the chat. We will monitor them throughout the broadcast and try to answer them live. If not, we'll make sure and have some time at the end for questions as well. So stay tuned. We will get started shortly at about 2 minutes after the hour. For those of you who just joined, we will get started in about 1 minute. And please use the chat or the questions portion of the tool to ask your questions. We will answer them throughout the broadcast and make sure to have about 10 minutes or so at the end to ask and answer even more questions. All right, so without further ado, we are at 2 minutes after the hour. My name is Ryan Wallner, and I'm joined here with Umair Mufti. Say hello. This broadcast will really focus on introducing you to the Portworx platform if you're new to it, and we will spend sort of the majority of the second half around Portworx Data Services. Umair will give you an overview of what Portworx Data Services is, as well as a demo, I believe. And throughout the broadcast, feel free again to ask any questions in the chat or the questions tool, and we will make sure to answer them. I want to make sure that is clear. It is a very informal format here, so we will do our best here. So for those who are not familiar with Portworx, it really is driving at sort of that cloud native stack for both the application builders and the data engineers, right? Whether you're developing applications that serve data, control data, manipulate data, store data, and are using Kubernetes for your application stack, there is a huge amount of information out there and different platforms you can use. And Portworx is really driving at enabling you to develop those applications on Kubernetes as a data platform. My mouse here, sorry about that. The big difference here is that the legacy infrastructure centric world is really focused on that storage wire to server sort of infrastructure. So really focusing on the storage admin, connecting LUNs and provisioning storage per server and divvying up those applications to those mount points. And that is, has worked well in the past for or traditional bare metal VM type workloads. But in this Kubernetes world, this cloud native world, we're really about application centric. And that's where we really focus on application first, what it needs, those abstractions that are provided in cloud-based storage and Kubernetes, and really allowing that application to be observable and dictate sort of what it needs in that infrastructure, such as on Kubernetes. Kubernetes really defines stateful applications in a very different way. So if you were new to Kubernetes, new to containers, right, the whole ecosystem started off really around stateless components. Applications were really not using storage in any fashion really think about web services, things that were not storing data to disk just yet. And now over time it's evolved, and Kubernetes does a really good job at solving that application orchestration problem and defining those abstractions. But really what it lacks is understanding those data management problems at scale and that cloud native space. So providing those granularities, the speed and scale, high availability, security, data protection, business continuity, automation around storage management and capacity management, and how to actually deploy these things in a production way. And that's where Portworx really helps define the new approach to container-based or Kubernetes-based storage. We often talk about the connector approach, which is really taking your initial existing investments, if you already have investments in storage, and those are connected to Kubernetes through plugins or the CSI interface, the container storage interface, and those are mapped directly one-to-one to a container in many cases. Whether that's a block volume or a file volume. And this works well for VM and traditional environments. When you start to think about the life cycle of those containers and applications on Kubernetes, these types of capabilities struggle under that scale when you're talking about many changes per day, many requests for that single pod, that single application, and sort of that limitation holds back the real scalability of the solution. So here we want to talk about that container native approach, which is deploying storage data management along with your applications, meaning that the storage data management layer is just deployed as part of that Kubernetes cloud native stack and is able to scale to thousands of containers, handle all those lifecycle operations, as well as provide those storage services in a container granularity way, meaning that we're not just configuring things like replication or high availability at a pool of storage, but really looking at the individual application, sort of going back to the application-centric view and providing those storage services like security and replication and disaster recovery at that very specific unit, which is the application, which is many resources on Kubernetes. And really, this is what we're delivering. Portworx is a Kubernetes native storage strategy that must deliver all these things, right? Abstract the storage and travel with the application. Again, focusing on the application. Be able to be used on-prem or in the cloud, no matter where you are. So pretty much any infrastructure, because we're doing the same thing for Kubernetes, the different applications for storage, we're abstracting it and making it really easy to use, but also scalable and providing those enterprise features. The scale of this, I mentioned, hundreds of storage operations per second, tens of thousands of volumes, really enabling that reliability no matter where you're deployed on premises in a hybrid environment or on cloud, and scale to large petabytes of storage and really interact with your existing workflows. And this is Portworx, right? Portworx Enterprise Data Services platform is focusing on providing these things in a cloud native way for Kubernetes and your cloud native stack. Portworx is divided up into a number of different modules. I'm going to briefly touch on each one of these, and then we're going to end with PDS and really dive into it. pxstore is the flagship product here you see on the left. And we're going to talk about pxbackup, DR, migrate, secure, and autopilot briefly. But again, this is really enabling this control plane on any infrastructure. So whether you're on, whether you're on premises or you need that flexibility, or you have that existing storage management or investment, you don't have to get rid of it. You can provide these abstractions on top of those existing investments. So whether you're using, local DAS, or have things like FlashArray or other SANs in your data center, or you're running on cloud, you can use these and still get all of these container native features and control plane objects. Again, cloud storage, bare metal, existing enterprise arrays, or pure storage, you're covered for every single one of them. So really any infrastructure anywhere. driving that home. In doing this, Portworx has been named a leader along with Pure Storage in the cloud native Kubernetes storage space. So again, we're not just telling you we can do this, we're also proving that we've done this, and we're really recognized as a leader in this space, if you don't believe us. And we have a lot of great customers that we can stand behind that use Portworx in production. So let's dive into the platform a little bit and start with pxstore. Right, pxstore is the software-defined storage layer. It provides that reliability and performance for volumes. It provides the replication layer, meaning you can configure individual container volumes, PVCs in Kubernetes to have one, two, three levels of replication, local snapshots, cloud snapshots, automation around capacity, meaning scaling those PVCs in real time, providing different storage tiers based on aggregated storage pools, and really creating that globally accessible storage pool for all your containers. It provides both block and NFS version 4 shared volumes, so read write once or read write many type volumes, and automatic failure detection, meaning that your application will not go down because Portworx is also aware of applications that use storage and can make sure that it uses a replica that's healthy across the cluster, even if node or network or disk failures happen. The next one is pxmigrate. It's the biggest component around data portability and application portability. It captures and moves both the application as well as the data in your Kubernetes stack, meaning it's not just looking at the PVC, the volume, and backing that thing up or moving that thing around. It's taking the application as a unit, and that unit is all the Kubernetes resources like config maps or deployments or stateful sets, as well as the PVCs and the physical, and the actual data in that volume, and making that a portable unit. It can move that application as a whole, or it can move an entire namespace or multiple namespaces, meaning that you can migrate a couple namespaces from one cluster to another across Kubernetes versions or platforms, on-prem to cloud, those kind of things, and provides some low versions of RPO. It doesn't provide zero RPO. That's really the DR component that we'll talk about. DR really goes to the next step. It takes that base cube motion technology and applies DR scenarios to it. So there's asynchronous and synchronous DR. Asynchronous DR is really around providing the cube motion on a schedule. So you can move and migrate your applications, the metadata associated with them, and the data in the volume on a schedule. So you're constantly updating, say, a warm site ready to fail over, and that provides low RPO failovers and RTOs for your applications based on the type of schedule, 10 minutes, 15 minutes, an hour. And this also can be provided across wide area networks or geographically dispersed clusters. The synchronous DR portion of this provides zero data loss, meaning that Portworx is spread across two clusters, but requires faster network, such as I think 10 millisecond round trip times. So very flexible disaster recovery techniques, everywhere from mission critical zero data loss to varying RPO and RTO levels. PX Autopilot is all about automation for capacity management. So when you provision your clusters on-prem or in the cloud, you provision only what you need with PX and PX Autopilot. Autopilot can then take a viewpoint perspective on those pieces of the cluster, meaning it will monitor the amount of storage you have for the whole cluster, and it will monitor individual application PVCs and be able to scale those based on a set of rules using metrics that it can get from the cluster. So if an individual PVC is 65% full, it can go ahead and scale that up and increase the size of that PVC. On top of that, if the underlying storage pool is starting to be filled up, it can scale that underlying storage pool by adding disks, expanding disks, or adding entire nodes and rebalancing the data across those expansions. This really helps with the total cost of ownership, really saving you a lot of money where you can provision only what you need. pxsecure is all about security. So encryption at rest, encryption in flight, bring your own key. So, KMS systems like Vault or IBM Key or KMS and AWS, you can bring those, use those, and integrate those with pxsecure. And it also provides role-based access controls and ownership of volumes to the actual data layer, meaning that Kubernetes does a great job at bringing role-based access controls to objects within Kubernetes, but really doesn't do anything at that data layer, because that's another, that's a different responsibility. Portworx brings that, and so you have dual ways to integrate with your RBAC, and it integrates with enterprise systems like LDAP. And corporate identity services like those. pxcentral is all about centralized management. So think of it as a control center, a single pane of glass for data and metrics aggregation, as well as providing dashboards, management consoles, alerts, and those logging and metric systems integrate with other tools like Stig and Datadog in the industry. pxbackup is the last one I think we'll talk about before PDS, which is a separate product. So it does not have to be used with PX Enterprise, meaning that you don't have to use pxstore to use pxbackup. If you're using Kubernetes and other storage systems, pxbackup can still be used. Of course, it does work really well with pxstore, enabling you sort of to back up your applications from any cluster and restore to any other cluster in Portworx. With Portworx 2.1 that was just integrated, we now enable you to do that for CSI backends and offload to the cloud and restore to other clusters, as well as back into Portworx volume. So if you're not running Portworx volume in one cloud or on-prem and you want to use a different type or Portworx volume in the cloud, you can absolutely do that as well. So really, pxbackup takes that application-centric viewpoint of the application, provides intelligent rules to make things application aware, so you can do syncs and run ad hoc commands before your backups are taken of the data as well as the application, and you can offload those to object stores to restore to different clusters. Again, this can be used as your backup tool. It has schedules, but also can be used as a migration tool, because you can back up from one cluster and restore to an entirely different environment in your enterprise deployments. And this is sort of that viewpoint of what I'm talking about when I talk about application view, right? So it takes those Kubernetes objects, the configuration and the data, and allows you to offload to, say, the cloud or an on-premise central archive, or even to a different cloud and restore to various other clusters for your data protection and business continuity needs, or even to offload for development reasons. The last one I will talk about is PDS in brief, and I will let Umair take over after this. Portworx Data Services is a layer that I view on top of all these things, right? It takes the best of breed things that we've done so far in the Portworx data management platform around PX security, migration, Autopilot, pxstore, and backup, and more, and provides database as a service on top of those for your Kubernetes applications. So it's a SaaS build service and takes care of those day one operations, day two operations, and enterprise backup for your databases. And I will stop there because I don't want to give too much away before Umair takes it over here. So let me hand over to Umair. If anyone has any questions, I will hop into the chat while Umair takes over the presentation and answer them for you while he really dives into PDS. So over to you, Umair.
Sorry, trying to show my screen. Hopefully you guys can.
Yeah, we see your whole screen, so.
Yep, let's go here, shall we? How's that? Can you guys see that okay?
I can, so hopefully that's a yes from everyone else.
Oh, I undo that, sorry.
I still see your presentation. You should be good.
Perfect. All right, thank you so much for that, Ryan. And I am gonna move some stuff around. It's complicated, this whole GoToWebinar thing. So quick introduction, my name is Umair. I'm the product manager on Portworx Data Services. As you as Ryan did a great job of laying out all of the existing things that the Portworx platform provides today, you saw basically all those building blocks of what the Portworx platform is, right? So DR, Autopilot, all those things, and really those are building blocks. And what we've been discovering as we talk to more and more of our customers is really that people don't necessarily want to build their own solutions with those building blocks. They really want a pre-built solution, something that's taking all those building blocks and building them into a building, right? And that's really what Portworx Data Services is. Instead of thinking about infrastructure now, we want our customers to be just thinking about their business needs, which are developing applications, right? And what is it that developers want? They just want data services. So this is kind of a departure for us as a company to kind of move up the stack, go away from software-defined storage and infrastructure and thinking about Kubernetes, and really start thinking about things at a higher level, which is applications. And again, this has come really from us having those conversations with many of our customers over time and realizing that the way they think about things are, as services on demand. And so that's what PDS is. It's a database as a service that can run on any Kubernetes cluster. So let's dive into that a little bit. So this is kind of some of the motivation of what it is or why we wanted to build PDS. What we've been seeing and I'm sure there's nothing new to most of you out there listening to this. Modern applications are built on modern data services, right? It's no longer the case that we stand up one giant Oracle rack and carve out schemas for our big monolithic applications, right? Cloud native data services or cloud native applications that people are writing these days have this notion of polyglot persistence. I may model a certain microservice with that needs a document store and the data model in another microservice might need a graph database or a relational database. And so what we see is that the needs of the data requirements for these applications has grown both wide and deep, because not only do we need to support many different modes of data service, right? But we also need to support many more of them at the same time. So whereas I previously had one single application, big monolithic application that had one backend, now that's 10 microservices. So that's 10 times the number of backends, plus those might be 5 different types of data services. So, so in this new cloud native development world, we're both seeing things multiply, going out wide and deep as well. So we have seen, and we actually commissioned a survey over 500, of 500 practitioners, both in the US and the UK. And what we found actually was that there are a lot of savings to be gained by running your data services in Kubernetes. And we've been hearing for a long time, obviously, that Kubernetes was not built for stateful applications. It's great for stateless applications. But having said that, many people are trying to do this. Many people do want to run their data services in Kubernetes because, let's face it, companies have made those investments in, whether it be in the cloud or their own on-prem Kubernetes clusters, and it doesn't make sense to run, your microservices in one sort of architecture and in one part of your data center, and then run your data services somewhere else. So we have been seeing people try to go on their own and try to solve these problems themselves. The ones that have been successful have realized many gains, and I'm not going to go through all these stats. I've left the slide up for a little bit. Hopefully you guys have gotten a chance to read through it. But basically, if you are running data services on Kubernetes, you'll be more efficient and you'll actually save time. Your developers will save time. So, and actually your data services team will save time as well. But having said that, it isn't easy. And so, like I said, that last slide reflects really the customers that have had success, or the companies that have had success running data services in Kubernetes. But at the same time, the thing, data services are difficult to run in Kubernetes, not so much because they're stateful applications, but because many of them are actually distributed applications, right? So when I think of a Postgres cluster, I don't just think of my Postgres primary. I think of the synchronous replication or the secondaries. When I think of a Couchbase cluster, I'm thinking of 3 nodes of a Couchbase cluster that all need to communicate with each other. And by and large, that is still difficult to do today in Kubernetes. And so doing things like automating, your day 2 operations with backup and restore. Think of data, data protection, moving your data from one cluster to another. This notion of data portability. These are all very difficult things to do out of the box with Kubernetes, or even if you spend some time on it, it's hard. And so again, sort of the motivation with PDS is we want to be that easy button for you to be able to do all these distributed stateful applications inside of Kubernetes. I don't need to spend time on this slide. Again, Ryan covered this, but basically Portworx as a company, as a brand, is the gold standard in Kubernetes storage. Everything that we have with Portworx Data Services is built on top of the Portworx platform. So you basically get to stand on the shoulder of giants. These are some of the existing customers. We flashed the slide a little bit earlier, so I'm going to skip over it here. But I'm going to jump into, again, sort of the holistic view of PDS and how it sits on top of Portworx. So at our base layer, we have the Portworx Enterprise platform itself. And again, as Ryan mentioned, kind of talked through, it's built on pxstore, plus the automated or these other functionality of being able to do autopilot and migration and backup. What we've added with PDS is the next layer on top of this. We've gone up vertically on top of the existing platform. And again, what we are delivering now with PDS are actual applications. It's no longer that I'm saying, hey, I can help you provision a volume in Kubernetes. I'm saying I can help you provision a Redis cluster in Kubernetes, or a Cassandra cluster in Kubernetes, or a RabbitMQ cluster. There's a number of applications that we'll be supporting. I should mention, I don't know that I brought this up yet. We actually have not GA'd PDS yet. We have announced it. It is in early access right now. And we have a set number of applications we're launching with, and those will continue to grow over time. And these are some of the logos you can see of the applications that we're intending to support. So with that, I'm actually going to kind of just kill the presentation and just kind of dive into it a little bit. So I'm going to just jump over here to this is actually a dashboard of PDS. And let me just start by saying the way that PDS works is PDS itself is a SaaS hosted control plane. You would come to a dashboard and use it to deploy your databases into your own Kubernetes clusters. So the important thing to note here is that you as a company or as a customer get to provision your own Kubernetes clusters, and those could be in the cloud, those could be on-prem, those could live anywhere. And you enable PDS through this control plane to basically communicate with your own Kubernetes clusters and deploy services there. And so we effectively are trying to run a managed data services, managed through software. And when I talk about deploying data services, it's not just day zero deployment. It's full lifecycle management of that database. So not only do we deploy the database, we automatically start monitoring it out the gate. We have application level metrics. We have infrastructure level metrics. We can do scaling out of your cluster. We can handle upgrades of your data services, and we can take regular snapshots and backups of your data and handle, like I said, all those components that Ryan mentioned with the DR and the migrate and the backup and all that stuff will be built into PDS. So again, we're in early access. I'm gonna kind of walk you through sort of the way it works right now. And I'm gonna actually peel back some of the layers and show you what's happening under the hood. Before this webinar, I went ahead and just deployed a couple of Cassandra clusters. I'll show you what they do, what a Cassandra cluster looks like through PDS. And then, if we have enough time, I'll actually just deploy one live in front of you so we can see how easy it is to actually do so. So again, this is early access. So most of the magic of what PDS is really under the hood. It's a number of Kubernetes operators. It's automation around creating Portworx storage classes and creating DNS entries and curated Docker images. And so the control plane that you're looking at is an early access thing. This is what we're just building on top of to show how the functionality is going to work. But we're still working on this. So just think of this as kind of like a POC for our UI. So like I said, before the webinar started, I just deployed a couple of clusters, or sorry, a couple of Cassandra clusters. You'll notice that I'm the environment that I'm specifying here. I have 2 backing Kubernetes clusters that I've connected PDS to, and I'm actually going to switch screens here for a second. Hopefully you guys can see this. Basically have some terminals open here that I'm running K9s in. If you're not familiar with K9s, it's a great CLI for kind of navigating around your Kubernetes clusters. In this tab, you can see I'm looking at my target cluster 1, and in this tab I'm looking at target cluster 2. And you can see that I've already pulled up here. I'm looking at a custom resource here, which is called Cassandra's. We basically have CRDs for every type of application that we deploy. So Elasticsearch, Console, all these different types will be represented as a dedicated CRD. And under the hood, what they're really just doing is automating all of the creation of the underlying Kubernetes resources. At the end of the day, the thing that you're going to end up with are pods that represent your Cassandra cluster. So I can jump into one of these pods, for example, and just do a node tool status, and you can see that this is like a functioning 3-node Cassandra cluster, right? But the process of creating that, there's a lot of pieces involved. So I'm going to kind of break this down for you guys and show you some of the stuff that's happening behind the scenes, and then again we'll jump back into the UI and take a look at what the actual customer experience is. But one of the things I want to point out is one of the things that the operator does is it actually creates storage classes, dedicated storage classes. And again, we leverage Portworx. So our provisioner here is the Portworx provisioner itself. And the beauty of this is that we get to use our best practices of what a Portworx volume looks like and how we should handle IO profiles and replication and anti-affinity rules, such that my Cassandra cluster that I just deployed, we can guarantee that each of the pods in the Cassandra cluster are scheduled on different nodes in my Kubernetes cluster. Not only that, but we can look at topologies of the Kubernetes cluster itself, and we can spread that out across availability zones, so that if there's any particular node failure in my Kubernetes cluster, I'm guaranteed to have a Cassandra node that's running, and I will have no data loss, right? I'll guarantee that there's actually replicas of those data that live on some other nodes. And we can do that because we understand the underlying Portworx volumes and how the replication works under the hood. One of the other resources that we create inside of Kubernetes is it's actually another custom resource, and these things are called these are DNS endpoints. So we use a third-party tool called external DNS. We link through and can create Route 53 rules for every pod that we deploy. It's important that we actually have a DNS endpoint so that we can actually provide ingress with a capital with a lowercase I. Ingress, just data ingress into your pods, and also provide service discovery so that you can actually just do a DNS lookup and hit one of your pods. So as an example, I had 3 pods in this Cassandra cluster, and I actually get a dedicated endpoint for each of these pods. What that allows application developers to do is really what they want when they're thinking about deploying a database as a service. They just want endpoints that they can use to plug into their driver, right? They want to say, my Cassandra cluster is 3 nodes. This is node 0, sorry. There could be node 1, and there could be node 2. And the beauty of this is that these host names don't change. These actually resolve to stable IP addresses, and they're backed by individual Portworx pods. So if the Kubernetes pod. So if the Kubernetes pod dies and the Kubernetes scheduler reschedules it on a different server with a new IP address, your application doesn't need to be reconfigured. These endpoints stay the same and are static and will automatically route to the backing pod. That's a notion, that's frankly speaking, that's one of the difficulties of running a data service inside of Kubernetes. We've long had this notion of ingress with a capital I, or load balancers and services for stateless applications. But it doesn't really make sense in a distributed application like Cassandra, where you want to direct specific read and write requests to specific nodes in your cluster. So that's one of the things that we provide out of the box with PDS. And then, obviously there's the PVCs and all those sorts of things that get created. But again, at the end of the day, you just end up with a bunch of pods that are running your data service. So let's jump back into the UI and take a look. So one of the things that I did when I created these clusters, when I take a look at the actual configurations or the object that was created when I deployed this Cassandra cluster, you can see these connection details. This is really what the user cares about and wants. These are those same endpoints. I, as a user, if I'm going to go deploy a Cassandra database using PDS, the thing that I care about are those connection details, and that's what's exposed here in the UI. When I deployed this, I actually created a backup schedule right out of the gate when I deployed this Cassandra cluster. I told it that I wanted it to run every Monday at 5 p.m. And you can see that it hasn't run yet, but what this will do under the hood, so this will actually schedule a cron job inside of my Kubernetes cluster. And on the schedule, it'll actually go and take a logical backup of the Cassandra cluster. And what we do is we have application-specific logic for every one of the applications that we support. And it takes a logical dump of that data. So Cassandra backup scripts behave differently than Elasticsearch, behave differently than Postgres. What we get is an application-consistent logical dump of that data. We put it into a dedicated Portworx volume, and then we take a snapshot of that volume and push it up into an object store. So it's located offsite for DR purposes. And that happens on a schedule, however the user wants to define that. And then, like I said, we're actually doing monitoring of these things out of the gate. Again, this is sort of an EAP, so you can see that we're still working on some of the visualizations of this stuff. But see, these are the underlying volumes that we're taking a look at for the databases that we've created. You can actually see the attached drives. If you want to get down into the actual Portworx, the Portworx PX Enterprise level, and you know about Portworx clusters themselves, you can actually dive down into it. And we're basically capturing all these metrics right out of the gate. These are some of the volume metrics that we have per volume. And again, we're going to be pulling in application level metrics as well, so you'll be able to see cache hit rates and IOPS per pod and that sort of thing. And we'll be pulling that back into the UI itself, so that it's all visualized here nicely. So that's basically sort of the what the promise of PDS is. We want to be the easy button for deploying databases, and let's go ahead and let's see if we can just deploy another Cassandra cluster real quickly. I should note, an admin would be able to come in here and specify exactly which applications users would have control over and be able to deploy. These are all images that we are curating and ensure that they'll run both on Kubernetes and inside of PDS itself and on our own Portworx platform. But if I want to run Cassandra cluster, I get to pick which of the curated images that are supported. I can pick which of my backing clusters I'm going to run this in, and then I can just give it a name. We have a notion of t-shirt sizing or plans. An administrator can come in and specify what sort of guardrails they want the downstream users to have in terms of what the configurations are for the cluster. And these can be both application level configurations. So I could say I want to enable auth N, auth Z for my Cassandra cluster, or specify heap size. And then there's sort of the global Kubernetes level resources in terms of like how much CPU or memory that I might be able to allocate for any particular cluster. So we'll just go with the small cluster here and hit create database. And that's really it. That's the experience we want for the user. It should be that easy to go and deploy a database. I should mention, this is all API backed. The UI that you're seeing, again, is just sort of like an early access version of our UI, but this is all API backed. So if you want to build a Terraform provider or some other automation to go and deploy these databases or do them in bulk, you certainly can. If we kind of jump back here into my target cluster 1, you'll see that this new cluster is starting to come up. It came up 35 seconds ago, and I can actually look at the status of the Cassandra object itself, see see the pod specific details for each of the nodes that's running in Cassandra. But not only that, I can actually, in my UI, I can actually see all that information too. So if I look at the status of this object, this is under the hood dynamically going and hitting the appropriate API server and fetching the real-time details and seeing that, this cluster is already healthy. It's got 3 nodes up and running, and if I wanted to see what the specific IPs of the pods are, I could. But at the end of the day, what the customer is going to care about is really that connection string. So yeah, so that's it at a glance. I could probably spend hours or days doing deep dive into any and all of this stuff, but I'm going to actually just open it up to questions at this point and hear what you guys are interested in learning about.
Thank you, Umair. So there are two or three ways you can ask questions. You can raise your hand and we will unmute you if you want to use your voice to ask those questions, or you can post a question in the chat or in the questions dialog here. And they can be on Portworx Data Services or Portworx or Kubernetes, anything you want really. So feel free to post your questions. Here's one. We have who will support the individual data services? Will it be Portworx or if I deploy Cassandra, what will it be?
Great question. So the platform, PDS itself, all the enterprise level stuff and the dashboard and the control plane, all that stuff will be supported by Portworx. The applications themselves, users will actually have options when they're deploying an application. I just showed you a deployment of a straight Apache Cassandra cluster, which means that there's no application level support for that. However, I could have chosen a DataStax enterprise distribution of Cassandra. And if I had chosen that, believe it or not, we would actually still provide service for that. You would call us, and behind the scenes, we would actually work with DataStax and ensure that application is supported. But we would effectively be the single throat to choke. So hopefully that wasn't too gory of a metaphor there, but yeah,
it's close enough to Halloween, maybe. I think that's fine.
Yeah, there you go. Yeah, exactly. So we want to be the single point of contact. And to be honest with you, part of this is based on, both Portworx and our parent company Pure Storage are very customer focused, like maniacally customer focused companies, and we want to ensure that our customer services is second to none. And a lot of times, and by the way, I'm going to speak as a former customer for a second. A lot of times I would call Portworx support for issues that ended up being hardware related or completely unrelated to Portworx itself. And the team would walk me through it and help me debug it, because they're really concerned about my success, not just debugging an issue. And we basically want to have that same philosophy with everything that's PDS related.
Got it. We have a two-parter question here from Trey. He asks, what type of release cycle for database versions will there be? I.e. Postgres 14 dropped recently. How long after releases will be for the CR and the image to be available? And along those lines, what images are being used for the applications?
Wow, great questions. So I'll start by saying this. Part of the PDS platform that you didn't see is all the automation to create the images. There's basically a whole CI process that's involved in this too. So that means that, I do want to be clear, we are using our own curated images. And that allows us to do the magic of, when I just did a no tool status, you saw that the Cassandra cluster automatically bootstrapped into a cluster, right? A lot of the magic to make that happen is logic that's baked into these images. The backup scripts that I talked about that knows how to take a logical dump of that particular type of data service. These are all sorts of conventions and specifications that we need our applications, our images to adhere to. So we do create our own images. Having said that, we've done a lot of work in automating that and creating a CI pipeline for the images themselves, such that for a minor version, for example, of a Postgres update, if I went from like 12.2 to 12.3, it really is like updating a config file, committing that into Git, and the automation takes over and builds that and pushes it up and runs through tests and does all that stuff, and then eventually ungates it to go into our into production. So we've done a lot of work on it, automating that and trying to make that as fast as possible. There are applications, like if we are going, for example, from Cassandra 3 to Cassandra 4, and there are architectural changes, or PG14, like you mentioned, that's just recently been released. There are some of those that we need to holistically look at and understand. Are there breaking changes that are introduced in this application that might break our actual automation? And so, I don't want to promise any sort of, timelines. Thank you. I'll say it won't be as slow as Red Hat is, but we aim to make these as fast as possible.
Okay, so I think you've answered both of those. If not, Trey, let us know. We do have a couple more questions here. The next one is from Joe, and that is Portworx an OpenShift operator in Red Hat Marketplace for on-prem Kubernetes? I can take that one. The answer is yes, absolutely. So Portworx itself, Portworx data management platform, and I want to make that clear, that's different than PDS, what we've been talking about, is available in is available to install as an operator through Operator Hub in the Red Hat Marketplace. So that answer is yes. The next question is, you mentioned, is from Luis, and you mentioned the integration with cryptographic key services. Is the expectation that the services, i.e. the IBM HPCS, would not encrypt the underlying block storage and all encryption would be handled by PX? I can also handle that one. The answer is both, right? So if you have encryption capabilities at the disk level or the block level that you're provisioning Portworx with, meaning that Portworx is an abstraction on top of underlying block storage. So if you provision Portworx, it needs a block device in order to install itself and aggregate and pool that storage across all your Kubernetes nodes. So those drives themselves can be encrypted. Although keep in mind that many Portworx volumes or many application volumes can have replicas on the same device, meaning that the underlying block storage device may have data across many different applications. And some customers may want the ability to encrypt individual volumes, meaning that one tenant or one application can have their own KMS key to encrypt at the container granular level, meaning that the individual PVC has its own key and not just the entire disk that may hold more than one replica of a volume. So hopefully that answers your question there. We had a few more questions here. What is Portworx resource website link to investigate more? Absolutely. So portworx.com is definitely the best place to go. But then there is, I will send you to docs.portworx.com as well. Let's see. I think I answered your question and with portworx.com, and then it just got rid of it. But docs.portworx.com, and then there's backup.docs.portworx.com for the backup components. But that will have all the documentation for Portworx, all the solutions and products, as well as links to access the EAP, how to sign up for it. I believe that's still open. Is it still open, Umair?
It is, although
okay.
yeah, the demand has been quite
quite
overwhelming.
So you can absolutely sign up though. It sounds like.
You can sign up. Just be patient with us. I hope you do sign up, because we do want to be able to follow up with you and honestly use this as an opportunity to really ask you guys what it is that you would like us to build as a solution. So we have a lot of stuff that we've always been doing and thinking about, but it's best to hear directly from what the actual needs are.
Yep, good point there. Joe, you are absolutely correct. You posted a question that says, I don't see a resource widget in GoToWebinar. Absolutely. That's actually, we'll take that as feedback. We don't have any direct links in here, but everyone on this webinar will actually get a follow-up. This is recorded, as well as an email, which has a whole bunch of links to where you can get to, but definitely portworx.com or docs.portworx.com, which has all the stuff we covered in the beginning, as well as links to PDS information. Trey says, thanks. You're welcome, Trey. We're here to answer your questions. And Luis, you said, yes, finer granularity is available. Good, yes. The encryption pieces, you can definitely use both. And it's really 3 layers, right? You can provide Portworx level encryption at the cluster layer, meaning that every PVC can have a single encryption key. You can have individual PVCs, as I mentioned, and also continue to use your underlying encryption. Really good questions. And that is, I believe that is all the questions I see here. I'm just double checking
Yeah, I
that
think
we didn't miss any here. Let's see. Okay. Yes, Joe, email forthcoming for a link. Yes, you will get the recording to this webinar. Absolutely.
Fantastic.
Okay, so that's all the questions I see so far. We do have a little bit of time left. I'll give it a few minutes just in case a question pops up for any of you, and we haven't left yet. I don't know if there's anything else you want to show in this time, but we'll give folks a few more minutes, and then we'll say thank you and head off.
Yeah, I mean, if I go any deeper, I can go really deep. So I think it's probably safe to leave it here and just invite people to reach out to me directly if you want, or again, deep dive follow up, or even any other questions that you may think of after the fact.
Absolutely. And I will just show, oops, here we go.
There we go. Off topic. Perfect.
Off topic. I like this, Trey. Of DS, PDS, but high level. What does it look like to have data in multiple regions? So depends on what type of configuration you are talking about. I'm going to guess 2 different Kubernetes clusters, 1 in each region, probably something like that. So Portworx, yes, thank you for confirming. Portworx has the ability to provide you asynchronous replication across regions. So in that case, you would have Portworx installed in each one of those regions, and we can provide replication level migration. So we talked about pxmigrate earlier. This allows you to provide a migration schedule object in Kubernetes. So it's a YAML file that you apply to your cluster, and it defines all sorts of things like what namespace it targets, whether you want the volumes and the data, just the data, or the application too, and it can migrate on a schedule, which is a schedule policy, another object which defines, how often is it, based on minutes or hours or days or once every month or those kind of things, to migrate data based on snapshots across regions. And the reason it has to be snapshot based across regions, mostly because different regions are often geographically separated by enough distance where network links can't support synchronous level replication, and Portworx obviously works at the block level replication layer, not a distributed file or anything like that. So we will be able to support it in that fashion. So the answer is asynchronous migration schedules. So you can constantly put data in another region as a way to quickly flip a switch and start using that new region as a DR capability, or as a migration policy from one region to another. As a follow-up, is there anything for, here's one for you, Umair. Is there anything for PG wall replication streaming built into the PDS, I believe he's talking about?
Yep, good question. So we're actually still finalizing all of our Postgres images and working on the, finalizing the functionality of them. We do when we do stand up the architecture is such that when we do stand up a Postgres primary, when we scale out the cluster, we actually do stand up secondaries as well. So we do have the synchronous replication going between the pods, and then we actually bundle PG backrest as well, and that handles all of the repos and the logical dumps of the PG data itself. As far as the wall files itself, it goes, PG pooler or PG bouncer. We actually, right now we're looking at PG bouncer, not PG pool. PG bouncer, I believe, gives us greater flexibility with both connection pooling and load balancing. So, cool. Sounds like you agree.
Great questions.
Yeah. Looks like, Trey, you have a use case for Postgres.
Yes, feel free to reach out to us if you wanted. Yes, he says yep. So we will absolutely be happy to talk to you individually, of course. We did get another question here in between, Trey, which is, what is the best resource if I need ELI5? Oh, is that Elasticsearch? Oh no, sorry, a ELI5 version of this webinar. I'm actually not familiar with what that is. I'm not a dev, nor am I working with Kubernetes myself, but I'm aware that our dev team is heading in this direction. Will you do a separate webinar for storage admins maybe in the future? So to answer the question in sort of a two-part, one is maybe if you could clarify ELI5, I would be happy to let you know if we have that.
I think he means explain it like I'm 5.
Ah, okay. Sorry, that's a new term to me. I learn something every day, I guess. So to answer your question is, we have a whole number of webinars really around these sort of monthly demos. We've done a number of different topics. I don't know if there's one directly at sort of for storage admins, but I will take that feedback to our team, and we can absolutely do some more generic content towards administration of storage in Kubernetes as it pertains to Portworx. That's a really good idea. So unfortunately, the answer is maybe, but I love the feedback, and I will bring it to our team to absolutely think about doing a focused webinar like that. Trey says also MongoDB beyond Postgres.
Yeah,
so I don't know if you.
But he claims that's easy, so I'll let him handle that.
Can handle that.
But no, I mean, you're right insofar as Mongo is a clustered database from the ground up, as opposed to something like Postgres, which really is not. It's not. Your point is well taken. Cool.
Okay, so All right, so we're 2 minutes towards the top of the hour. I want to thank everyone who joined today. I really appreciate the great conversation, the great questions at the end here. If you do have any follow-ups, again, we will send out an email with this recording. Also, we are available if you want to reach out. Trey, it sounds like we'll be in touch if you want to dig in some more. And thanks for coming, and appreciate it. Until next time, we do one of these every month. Take care, everyone.
Thank you.